Okay, division with polynomials. So let us start on. Let's just divide some. Let's say that we have.
I don't think you're recording at the moment.
I think I am. 3x cubed, and if I'm not, then we just won't have a recording of this. Plus 5x squared plus 6x minus 4 divided by x minus 2. So we have a polynomial, which is this, and we have a divisor, which is this. And we're going to do the division. We're going to do long division, just like how you probably first learned how to divide.
Yeah, I hate long division.
So we're going to say, I want x minus 2 divided into 3x cubed plus 5x squared plus 6x minus 4. Okay. So, what we ask is this. First thing we ask is, how many times does x go into 3x cubed? Right? Or so 3x cubed divided by x is 3x squared. And the idea is, when we multiply this by this, that these two terms are the same so that they will subtract down and be gone, right? So now we're going to multiply 3x squared by x minus 2, giving me 3x cubed minus 6x squared. Okay, we're going to put a bar down. We're going to subtract now. 3x cubed minus 3x cubed is 0. 5x squared minus negative 6x squared is 11x squared. And we're going to bring down the 6x. And we're just going to repeat the process, right? So we're going to say, how many times does x go into 11x squared? 11x times, right? Or you're really asking 11x squared divided by x, or what do I multiply this by to get that? Which is usually the way I do it. It's just, what do I multiply this by to get that? Okay, by 11x. You know, you're really doing the division operation, but you don't have to think about it that way. Then the 11x multiplies the x minus 2, giving you 11x squared. And then what? Minus 22x. And then subtract. The 11x squareds are gone. We don't need to subtract those, we know, because we set it up so they would be gone. And what do we get here? 28x. Because when you subtract a negative, and we bring down the minus 4.
I have all the signs wrong every single time.
So what do I multiply x by to get 28x? 28. So we put a plus 28. And we multiply, giving me 28x minus 56. And we subtract, giving us 52. The 52 is the remainder. The original expression is the polynomial. The divisor is the divisor. And the result of doing the division is called the quotient. Okay? So that's just naming all of the different stuff there, right? We started with a polynomial divided by a divisor. Okay? So really probably just put that there. So we've got two ways we can express this then, right? We can write this as, what we have is a polynomial is equal to, the polynomial is equal to the divisor times the quotient plus the remainder. Okay? And we can write that as function notation as a polynomial in x is equal to the divisor in x times the quotient in x plus the remainder. Which, note, does not have an x. Because the remainder is a constant in this case. And another way we can write this is that a polynomial divided by a divisor is equal to the quotient And all that is doing is either going through and dividing everything by d of x, right? So we're dividing every term. And just expressing it in the form of, hey, something divided by something gives you this plus the remainder, which is the remainder over the divisor, right? Okay, so those can be written in the two different ways. So for the given example, then, we could write, I'm not going to be able to squeeze this in probably, but what was it? 3x. Right, real small. So 3x cubed plus 5x squared plus 6x minus 4 is equal to x minus 2 times x squared plus 11x plus 28, x squared plus 11x plus 28 plus 52. Okay, so if you multiply this out, you're going to get x cubed plus 11x squared minus 2x squared. Right, hang on. Oh, there's a 3. It's 3x squared here, right? 3. Okay, so you're going to get 3x cubed plus 11x squared minus 6x squared, which is plus 5x squared, plus 28x minus 22x, which is plus 6x, minus 56 plus 52, which gives you the minus 4, right? So if you expand that out and add the 52, you get back to there. And the other way to write it would be like this. So you'd be writing 3x cubed plus 5x squared plus 6x minus 4 over x minus 2 equals 3x squared plus 11x plus 28 plus 52 over x minus 2. And if you multiply everything by x minus 2, you're just going to end up with this, and then that. Okay? So, just two ways of writing a long division. Okay, I'll give you a moment if you want to copy stuff down.
Exact same thing like this.
All right, so then do it. Go ahead.
Go, half a second.
X cubed divided by x is x squared. Multiply x cubed minus 3x squared. Subtract, get a positive x squared. Minus 23x. X squared divided by x is x. Multiply, get x squared minus 3x. Subtract, get minus 20x plus 60. Negative 20x divided by that is minus 20. Gives me minus 20x plus 60. Gives me a remainder of 0. So this divided in evenly. Okay? Which is really, in this case, p equals dq. I'm just leaving off the x's at this point. Saying the polynomial is a divisor times the quotient plus the remainder, but the remainder is 0. So in this particular case, polynomial is divisor times the quotient, which means that x minus 3 is what? In relation to this?
A factor.
It's a factor. Okay, it's a factor. Since it goes in evenly, there's no remainder, then it's a factor of that. Which means that we could then write x cubed minus 2x squared minus 23x plus 60 is equal to x minus 3 times x squared, what was it? Plus x minus 20. Damn, ran out of ink. Plus x.
Smart boards right now,
X minus 20. Okay, which is x minus 3 times
x plus 5 and x minus 4.
So there we go. Now we have the fully factored form of that cubic. So before we didn't know much about this. Now we could draw a graph of this, fairly accurate graph, right? Because we know where the zeros are, which are, where are the zeros? 3, negative 5, 4, and the y-intercept is 60. Okay, so we can draw a nice accurate graph of this. The end behavior is
It's degree 3 and it's positive.
we go left to right. Quadrant 2 to quadrant 1. Quadrant 3 to quadrant 1.
It's cubic.
Yeah. Okay, so it's quadrant 3 to quadrant 1 because it has what? Why do we know that? Why isn't it quadrant 2 to 4?
Because it's positive.
Positive leading coefficient, right? It says it's starting negative and it's going positive. Okay, in quadrant 3. That's sometimes the way that end behavior is described, is like negative to positive. So starting out negative, going to positive. I like the quadrant thing a bit more than that. Positive to positive is another, right? But that would just be 2 to 1. Negative, positive to negative, would be 2 to 4, etc., etc.
Hard question.
Yeah, hard question. Do the homework.
So the lesson's over?
Yeah, lesson's over. I'd stop it if I could.